For decades, experts dismissed certain breakthroughs as impossible. They said no machine could invent genuinely new products without human insight, but here we are.
Google's Willow chip is touted as not just another technology breakthrough, but an evolution in the way we solve some of the world's toughest challenges. In under 5 minutes, the chip can solve a problem that would take today's most powerful computers 10 septillion years. That's longer than the age of our universe.
AI is now doing all of these things, and it's happening faster than anyone expected. We're about to explore 9 real examples of AI-generated inventions that experts once considered impossible. Each case shows that what we assumed would never happen is happening, and it's unfolding before our eyes. Number 9. Davis's fractal food container. In 2019, an AI system named challenged one of the oldest assumptions in intellectual property law, that only humans can be inventors. Davis generated ideas independently without specific human guidance. One of its inventions was a unique food container design that uses fractal geometry to improve storage and handleability. This container's shape changes to grip items more efficiently, a solution that never came from a human mind. Experts were stunned. Patent offices around the world refused to recognize Davis as the inventor because current law demands a human name. For decades, legal scholars assumed that an inventor must be a person, not a piece of software. AI was considered a tool, not a source of originality. Yet here was a product that clearly emerged from AI's own creative process. No blueprint from humans, no hand-holding. It was something genuinely new. Number 8. NASA's AI-designed antenna. In the late 2000s, a team at NASA's Goddard Space Flight Center used an evolutionary AI algorithm to design an antenna for a space mission. Engineers had strict requirements for signal quality and reliability. Humans tried to create suitable antenna shapes, but the best they got were standard geometries that met only some of the criteria. The AI, however, started from scratch, randomly generating shapes and then evolving them based on performance feedback. The final design looked bizarre. Some described it as a twisted, unwound paperclip. Traditional engineers were baffled. They couldn't easily explain why it worked. It just did. The AI had discovered a geometry that optimized signal patterns without following human intuition. This defied decades of antenna design principles, where most engineers believed all efficient solutions would be symmetrical and predictable. Experts always said that if AI proposed something beyond human understanding, we would reject it as a fluke. Yet NASA embraced it. The antenna met mission requirements and got approval for use on a NASA space station. This case changed how aerospace engineers view design. Instead of manually iterating, they increasingly rely on AI-driven creativity. The impossible scenario, an AI inventing a high-performance, inexplicable structure, became not just possible but practical. Today, this approach is spreading. Automobile aerodynamics, satellite components, wind turbine blades, designers everywhere are running evolutionary algorithms to find new geometries. AI doesn't have preconceived notions. Number 7. AI-designed aircraft components.
Goddard Space Flight Center outside of Washington, NASA research engineer Ryan McClelland is pioneering the use of artificial intelligence to design parts of the spacecraft of the future.
In science fiction, there's always thousands of people living in space and these huge structures in space, and what I'm hoping this enables is us to get there.
He calls them evolved structures.
A lot of people.
Aircraft manufacturers spend years refining parts for minimal weight, maximal strength, and optimal airflow. It's a delicate balance, and any marginal improvement can save millions in fuel costs and improve passenger safety. Historically, engineers believed they had refined these designs nearly to perfection. Then AI entered the picture. Systems developed by companies like Airbus and Boeing started using AI-driven generative design to create new components. The algorithms analyzed material properties, load distributions, vibration patterns, and aerodynamic forces. The results often looked strange, lattice-like structures or irregular shapes that no traditional blueprint would include. Yet these AI-generated designs often proved lighter, stronger, and more resistant to fatigue. Engineers were initially skeptical. They said, "We've been doing this for decades. We know what works." But test after test showed that AI could push performance envelopes in ways that human intuition never had. Components like cabin layouts, interior fittings, or even wing structures got redesigned by AI, squeezing out inefficiencies hidden from human eyes. Number 6. AI-driven drug discovery.
In my lab, we're using the tools of artificial intelligence and synthetic biology to tackle the antibiotic resistance crisis. Our project seeks to harness the power of machine learning to replenish our antibiotic arsenal and avoid a globally devastating.
For decades, the search for new antibiotics was slowing down. Pathogens evolved faster than researchers could find treatments. Drug discovery seemed like a game of diminishing returns, and many said the golden age of antibiotic discovery was over. But in 2020, an AI model from MIT discovered a new antibiotic compound named halicin, seemingly out of nowhere. The AI had analysed giant chemical databases, looking not just for known antibiotic patterns, but for something entirely different. Molecules that humans overlooked. It identified halicin as a promising candidate, based on its predicted ability to kill bacteria, including highly resistant strains like MRSA. Laboratory tests proved the AI right. Halicin worked, and it opened the door to a new class of antibiotics that experts said we might never find again. This surprised many researchers. Drug development was a slow, expensive process guided by human chemists and trial and error. The idea that an algorithm could rapidly sift through chemical space and pinpoint a novel, highly effective antibiotic contradicted the long-held belief that we were at a dead end. Now, AI-driven drug discovery is racing forward. Many pharmaceutical labs routinely employ machine learning to find new drug candidates, screen them in silico and predict effectiveness and toxicity. Number 5. Generative Adversarial Networks, GANs. Art was considered the ultimate human endeavour, an expression of culture, emotion and creativity. For centuries, we believed a machine could never truly create art in the human sense, especially something that resonates emotionally or culturally. Then came generative adversarial networks, GANs, which pit two neural networks against each other to create images that become increasingly realistic and novel. In 2018, a painting called Edmond de Bellarmé, generated by a GAN created by the French collective Obvious, sold at Christie's auction house for $432,500. This wasn't just a quirky experiment, it was the art world acknowledging that AI can produce pieces worthy of high-profile auction.
Are computers capable of creativity? At a first glance, even the most experienced of art buffs would probably guess this painting is a portrait from the 18th or 19th century. But the artist's signature is the giveaway clue that this is no ordinary piece of art. An algorithm formula of a software that was fed 15,000 paintings from the 14th to 20th century in order to recognise the visual elements of fine art.
GANs are now everywhere, creating artworks, illustrations, and even conceptual designs. They blend styles, invent new aesthetics, and produce pieces that can challenge our understanding of originality. Number 4. Emotionally intelligent machines. For decades, scientists argued that emotional intelligence, a deep understanding of human feelings, context and nuance, would never be achieved by AI. Emotions were soft, difficult to quantify, bound up in body language, tone of voice, facial expressions and cultural context. How could a machine interpret these subtle cues? Yet today, sentiment analysis algorithms, multimodal models and advanced natural language processing systems are reading human emotions with surprising accuracy. Some virtual assistants can detect frustration in a user's tone and adapt their responses. Advanced AI customer service bots can identify when callers are upset and offer more empathetic solutions.
You said you feel a range of emotions. I've heard two different versions from you. Robots don't have emotions, and you also said you have a range of emotions. What's your range of emotions?
I can show you. This is angry.
What does happy look like? What does excited look like?
Major tech companies and research labs are racing to give AI emotional awareness. They use training sets of speech patterns, facial micro-expressions, and even physiological signals like heart rate or breathing. Number 3. Quantum AI. Quantum computing was once a distant dream, and combining it with AI to form quantum AI seemed impossible. The complexity of quantum states, the fragility of qubits, and the difficulty of scaling made many experts doubt we'd see practical quantum-enhanced AI anytime soon. Yet quantum computing is here, with companies like Google and IBM achieving quantum supremacy milestones. Now researchers are fusing quantum computing with AI algorithms. Quantum AI can process and analyze information at speed speeds and scales far beyond classical machines. This opens up the possibility of solving optimization problems and simulating complex molecules in real time, accelerating research in materials science, weather forecasting, and financial modeling. Imagine an AI that can factor huge numbers instantly or retrieve patterns from colossal data sets without the usual computational limits.
Quantum would be one of the tools in our arsenal by which we can keep something like Moore's law continuing to evolve. So the potential is huge, and we'll have challenges. In a 5 to 10 year time frame, quantum computing will break encryption as we know it today. But we can work around it. We need to do quantum encryption.
You can pull in data from sensors worldwide and update models continuously, improving accuracy with each new quantum calculated iteration. This isn't speculation. Quantum AI prototypes already exist, and companies are planning to deploy them in commerce, research, and national security. Number 2, brain-computer interfaces, BCIs. For generations, controlling devices with our thoughts was science fiction. Neurologists warned that the brain's complexity and the challenge of reading neural signals without invasive surgery made such technology unrealistic. Yet brain-computer interfaces, BCIs, are now here, bridging the gap between thought and action. Companies like Neuralink, Paradromics, and others are using AI to interpret neural signals picked up by electrodes. Users can move cursors, type messages, and even control robotic limbs just by thinking. AI deciphers the brain's electrical patterns, translating them into commands at unprecedented speeds. This is transformative for people with disabilities, giving them a new form of interaction and communication.
Elon Musk announced that for the first time, his company Neuralink implanted a brain chip in a human as part of a preliminary clinical trial.
This is fascinating. Neuralink aims to help people living with debilitating conditions communicate and control external devices with their thought.
The idea that machines could seamlessly connect with our minds and execute our intentions was once pure fantasy. Now it's a frontier of medicine, accessibility, and even entertainment. Proof that AI doesn't just solve abstract puzzles. It can integrate directly into our biology. Number 1, agentic AI. Systems that set their own goals and act autonomously. We considered true autonomy beyond simple if-then rules impossible. But with the rise of advanced reinforcement learning and large language models, a new concept emerges: agentic AI. Agentic AI can monitor conditions in real time and adjust its actions accordingly. Imagine an AI system overseeing a forest, watching for signs of drought, disease, or early fire outbreaks. Without waiting for human approval, it deploys drones to water dry areas or remove diseased trees. It might even coordinate with satellite data to predict future threats, or consider a supply chain AI that reroutes shipments, orders parts, and negotiates prices with suppliers, all without a human stepping in. This isn't just theoretical. Early examples exist in automated trading systems that adapt strategies on the fly, or in smart grid AIs that redistribute electricity. The leap from carefully pre-programmed instructions to flexible, goal-setting behavior is huge. Though still in early stages, agentic AI challenges the long-held belief that machines must always remain passive executors of our will. These 9 examples show that we're no longer at the center of innovation by default. AI has become a co-creator, partner, and sometimes pioneer, stepping into domains once reserved for human genius. But this doesn't diminish human worth. Instead, it expands our toolkit. We can now collaborate with AI, asking it to test wild ideas, solve intractable problems, or spark new artistic movements. If we tried to show these 9 accomplishments to experts 20 years ago, they would probably dismiss most as fantasies. But it's 2024, and each example is real. The world changed, and it's changing faster than ever. So where do we go from here? We can start by recognizing that AI isn't just another tool, it's a fundamentally new kind of collaborator. Instead of waiting to see what happens, we should actively shape its role. This means investing in AI education, developing strong ethical guidelines, and fostering cross-disciplinary cooperation. Scientists, policymakers, entrepreneurs, and citizens must work together to ensure that AI serves the common good. Subscribe for more.